Good day everyone, my name is Nathaniel and I welcome you back to Global Education Zone. And today in our further maths class, we'll be talking about what? Surds. So what are surds? Before we talk about surds, we'll talk about calculations in surds. And before calculation in surds, we'll talk about what surds really are. First, talk about what surds really are, we have to consider what the nature of surds are. And we have to understand what rational and irrational numbers are. A rational number is basically a number that can be expressed in the ratio of two numbers, up and down. And I mean a rational number can be expressed in the form of P over Q, where P and Q are both real numbers. But an irrational number cannot be expressed as a ratio of two numbers. Examples of rational numbers are 1, 2, 3, 4, and so on and so forth. This ellipsis, this dot means it goes on till infinity. But irrational numbers are roots of numbers, cubes of numbers, and so on and so forth. Like roots, the square root of 2 is an irrational number because you cannot express it as a ratio of two numbers, two real numbers. And a real number is a number that can be expressed in a number line. Something like 0, 1, 2, 3, they are all real numbers. Then we also have positive numbers from 1, 2, 3, 4, 5, 6, 7 to infinity. So now, what are surds? Surds are types of irrational numbers. Surds are specific type of irrational numbers. And under surds, in this specific class, we'll be talking specifically about quadratic surds. Quadratic surds are surds that are formed as the square root of numbers. Examples of quadratic surds are root 2, root 3, root 5, root 7. All these roots of numbers that cannot be accurately found. Like root 2, for example, is 1.414. It goes on and on and on. Now 1.414 is an infinitely long number and it's a surd. So anything that has a root is called a surd. And those surds, they are often surds of numbers like 2, 3, 5, 7. But surds, basically, which are quadratic, always have the square root on top. So that's what we're talking about today. We're talking about quadratic surds. So let's continue. Now we'll talk about the rules of surds. There are different rules of surds. There's a rule that says that root A times B is equal to root A times root B. So this is separation of roots. So if root A times B will equal to root A times root B. So that's one principal rule of surds. Then another principal rule of surds is the rule that says that root A over B is equal to the square root of A over the square root of B. So that's also the separation of roots. So these are the two principal rules of surds we'll be working with. And an example of that is, let's say root 3 times 4. Root 3 times 4, that will give us root 12. So this root 3 times 4 is also root 12. I can also call this what? Root 3 times root 4. And this is an example of this. Root 3 times root 4 is equal to root 3 times root 4. Now, when we have this quotient, we can also write it as you can say root 9 over 3 is equal to root 9 over root 3. So surds can be separated and combined. That's one essential rule of surds. Next, we're talking about basic form of surds. Basic form of surds are the lowest form that surds can be expressed. Now, let me give an example. Something like root 162, root 162. Now, this form is a compounded form. It's not in a basic form yet. Now, to express it in its basic form, we'll divide by 2 first. Let's divide 162 divided by 2 will give us what? 81. That's 81. And let's not forget that we divided by 2, so I have to go to multiply by 2 again. It's 1 times 2. So there's a balance here because 81 times 2 will still give us 162. Now we'll now look at this. Look at the first rule of separation of surds. So we can separate these surds, right? We can say root 81 times 2 will be root 81 times root 2. Root 81 is what? Root 81 is 9, right? That will be 9 times root 2. And that will also be what? 9 root 2. This is one essential question in Surds that embodies the basic rules of Surds. Next, we'll talk about similar Surds. Similar Surds are like Surds in the same family. Similar Surds are Surds like root 2, 3 root 2, 7 root 2, and so on and so forth. So basically, a similar Surd are multiples of the same Surd. So root 2, 3 root 2, 7 root 2, what's common with them? They are all multiples of root 2. So those similar Surds, one property of similar Surds is that it can be added and subtracted, unlike other Surds. I can say root 7 root 2 minus 3 root 2. You can get it as 4 root 2. So when you want to manipulate similar Surds, you look at the coefficient of that root 2. They are both coefficient of root 2 are 7 root 2 and minus 3 root 2. Now that 7, you do 7 minus 3, that will be 4. Then now replace root 2, that will be 4 root 2. That's how to work it. Next, we'll talk about another principle of Surds, which is conjugate Surds. We'll talk about conjugate Surds now. Conjugate Surds are Surds which, when multiplied, give a real number. Example of this, let me give what? An example. 2 minus root 2. Now this Surd, there will be a number, another particular Surd that I will multiply with this Surd to give me a real number. So let me try. The conjugate of this Surd will be 2 plus root 2. So when you want to form the conjugate of a Surd, you look at any multiplication sign, you ignore the multiplication and division sign, then you face the addition and subtraction. If it is subtraction, it will change to addition in the conjugate. If it is addition here, it will change subtraction in the conjugate. So they have inverse addition signs. So if it's addition, it will turn to subtraction in the conjugate. If it's subtraction in the result, it will turn to addition in the conjugate. It's like opposite. Now, for any single Surd, the conjugate of a single Surd is the Surd itself. Like for something like root 2, the conjugate of root 2 is still root 2. So when you multiply root 2 by root 2, you get 2. And this 2, as I mentioned earlier, is a real number, while root 2 is not a real number. So the conjugate of a Surd is any other Surd that when you multiply with a Surd will give you a real number. So when you multiply them together, or when you give the product, it gives a real number. Now, let's work on conjugate of Surds. Let's provide the conjugate of Surds. Let me give an example. Write down the conjugate of each of the following Surds. Let's write down the conjugate of some Surds. So one Surd I'll be giving today is root 3 minus root 2. Root 3 minus root 2. Root 3 minus root 2. So obviously, if we have to find the conjugate of this Surd, what you need to do is change the sign. From root 3 minus root 2, the conjugate will be what? It will be root 3 plus root 2. So our conjugate of this Surd will be what? Root 3 plus root 2. In another video, we'll continue on Surds. Thank you for watching.